Hello students, I welcome you all to the e-learning sessions of LJ Institute of Engineering and Technology. Myself Hardik Shah and I am here to share my knowledge with you all in the subject of automobile engines. Okay, so we are already started a new chapter on the combustion of SI engine and CI engine. Okay, and our today's topic in this video is normal versus abnormal combustion in SI and CI engine, and we will also see what is knocking and detonation and different factors affecting it in a combustion in SI and CI engines. Okay, so I hope you will see this video till the end to completely understand this topic and gain your skills in automobile engineering. Fine, so let's start our video. So in conventional SI engine, the fuel is completely vaporized and homogeneously premixed with air and residual gases. Okay, so when the combustion occurs, it happens and it is called normal combustion, right? So under normal operating conditions, the mixture is ignited by the spark plug in optimized moment of cycle, that is 20 to 40 degree before TDC as per Waldheim diagram. Okay, so usually three combustion phases are distinguished depending on the processes, right? And we have already discussed in a previous video, that is ignition delay, flame propagation and afterburning. These are the three stages and it is called normal combustion. Okay, so we can say that the combustion is normal when two conditions are satisfied. One is the ignition of the combustible mixture is controlled by the spark plug, okay, with present timing, and after the ignition, second one, after the ignition, the flame propagates regularly to the whole mixture without sudden increment in the velocity. Okay, so when these two conditions of the normal combustion do not occur, the combustion process is abnormal, causing the engine damage and simply performance will be worse, or you can say noise will be produced. Okay, so there are two forms of abnormal combustion in SI engine. First form is surface ignition and second form is knock, or you can say knocking. Okay, so what is surface ignition? So the combustion originates from some hot spot in a combustion chamber, that is called hot spot. Okay, the flame front generated by the surface ignition is really similar to the turbulent generated by the spark plug, but in this case the moment of ignition is not controlled. The pre-ignition is most dangerous because it advances the ignition moment. Okay, therefore the usual work output decreases temperature and pressure of the working fluid, which actually increases. Okay, this process is self-increasing until some engine component collapse. This problem can be solved by a proper design of the engine and use of good quality lubricants. Okay, so that was the surface ignition. Second one is knocking. The fresh charge auto ignites before being reached by the flame front. It is caused by the high temperatures and pressure reached within the cylinder. Okay, so the high release of the energy due to the sudden combustion of a large mass of end gas produces a significant local increase of the gas pressure, which causes a shock wave in a propagated form the auto ignition point through the combustion chamber. Then the pressure waves are repeatedly reflected by the walls and they create an oscillatory pressure versus the time. Okay, so knock is the name which actually we have given. Okay, knock is the name given to that metallic noise or metallic sound like hammering, okay, produced by the vibrations of the engine components excited by the pressure oscillations. Okay, so knock intensity depends on the amount of end gas mass that auto ignites. So what will happen if there is knocking in engine? So these are the main effect of knocking, or you can say detonation in SI engine. First effect is noise and vibrations, thereafter mechanical damage, thereafter carbon deposits, thereafter increase in heat transfer losses is also there, thereafter decrease in power output, thereafter decrease in thermal efficiency also, and last one is pre-ignition. So these are the effects that are happening due to the knocking or detonation in SI engine. So what is the reason of all of this? So let's see the main engine parameters which influence the knocking tendency. First one is compression ratio. So at high compression ratios, even before spark ignition, the fuel air mixture is compressed to very high pressure and temperature, which promotes auto ignition, or you can say self ignition, right? Second one is engine speed. So at low engine speeds, the flame velocity is very slow and thus the burning time is very long. This results in more time for auto ignition. At high engine speeds, there is less heat loss, So the unburned gas temperature is higher, which promotes the auto ignition. Third one is spark timing. So maximum compression from the piston occurs at TDC, increasing in a spark advance, make the end of combustion at crank angle. Fine. So this leads to high pressure and temperature and presence of end gas that increases the risk of knock. So spark timing is set almost 1% below the point of MBT to avoid the situation. So fourth one is inlet pressure. So increasing the inlet pressure of an engine translates to increasing the amount of air fuel mixture inducted into the engine cylinder, which in turns releases the high combustion energy and also increases the tendency of auto ignition and knocking. Okay. Fifth one is inlet temperature. So an increase in the air fuel mixture inlet temperature increase in the reactivity and increase the chances of auto ignition of the air fuel mixture during the compression stroke before power stroke. Okay. Thereafter next one is in cylinder flow conditions. So increase in turbulence and swirling in the combustion chamber enhances the mass burning rate of the mixture, which enhances the combustion. Okay. And seventh one is combustion chamber geometry, means design of combustion chamber. So the shape of combustion chamber and the location of the spark plug is very important, right? The location of the spark plug influences the combustion rate. The faster the combustion of the mixture, the lesser the tendency of knocking in the engine. Okay, so the combustion chamber shape also determines the in-cylindrical flow conditions. So these are the main 7 parameters which actually influences the knock tendency in SI engine. Fine, we have to keep it in mind. So now let's see what is about CI engines. So there are basically 4 stages of combustion in CI engine, right? So first one is ignition delay, in which there were two phases, physical delay and chemical delay. Fine. Second one is uncontrolled combustion. Third one is controlled combustion, and fourth one is after burning. Okay, that we have already discussed. So there are different parameters controlling the abnormal combustion in CI engine also. So you can say abnormal combustion means we can say knocking. Okay, so what are the factors? First one is compression ratio. Greater the compression ratio, the temperature in the cylinder are higher. Hence, due to the high molecular activity, the ignition delay will be less and the chances of abnormal combustion are very less at very high compression ratio. So in diesel engine, high compression ratio is required. Okay. Second one is cylindrical wall temperature. So if the cylinder wall temperatures are high, the delay period will be less and hence the knocking will also less. Okay. Third one is delay period. So the delay period must be small. If the delay period is large, more fuel will be accumulated in the engine. Okay, and it will burn suddenly. Okay. Fourth one is inlet temperature. For smaller delay period, the inlet temperature must be high. Okay. Fifth one is self-ignition temperature. So self-ignition temperature must be low so that less time is required to reach the temperature. Therefore, only small amount of fuel burning in controlled manner. Okay. Sixth one is ignition advance angle. So if the ignition advance angle is advanced, or you can say more, the fuel injection starts at low pressure and low temperature, and due to this low temperature, the delay period will be large and hence more fuel will be accumulated in the cylinder and it may burn in uncontrolled manner. So this is not desired. Fine. Seventh is engine speed. The fuel injector is geared to the engine and hence the injection remains constant in a crank angle. Fine. So if the speed is increased, the duration of the injection time decreases and hence the high speed ratio or higher speed, more fuel is accumulated in less time. Hence the CI engine, the chances of abnormal combustion are very high at the high speeds. Okay. Thereafter, using the better fuel, or you can say, so using a good fuel reduces the knocking tendency. Okay. Ninth one is knock reducing fuel injectors. So this type of injectors avoid the sudden increase in pressure inside the combustion chamber because of the accumulated fuel. Okay, so this can be done by arranging the injector so that only small amount of fuel is injected first. Then what is happened? This can be achieved by using 2 or more fuel injector arranging in a phase. Okay, so now let's see what are the main difference, or you can say comparison between the SI and CI engine knocking. Okay, so first one is self-ignition temperature, okay. Second one is delay period, so it should be long in SI, short in CI engine. Thereafter CR, compression ratio, low in SI, high in CI. Inlet temperatures, low in SI, high in CI. Inlet pressure, low in SI, high in CI. Okay. Thereafter speed, so it should be high in SI and low in CI engine. Combustion chamber wall temperature, it should low in SI and it should be high in CI engines. Fine. So we can say that in spark ignition engines, auto ignition of the end gas occurs away from the spark plug, most likely near the end of combustion, which causes the knocking. But in compression ignition, CI engine, what happens? In compression engines, the auto ignition of the charge causing the knocking occurs at the start of combustion. Okay, that was the first point. Second, in order to avoid the knocking in SI engine, it is necessary to prevent auto ignition of the end gas to take place at all. In CI engine, the earliest auto ignition is necessary to avoid knocking. Okay. Third one is the knocking in SI engine takes place in homogeneous mixture. Therefore, the rate of pressure rise and maximum pressure is considerably high. In case of CI engines, the mixture is not homogeneous and hence the rate of pressure is very low in SI engine. Okay. Thereafter next one is in CI engine, the only air is compressed. Therefore, there is no question of pre-ignition in CI engine, as in SI engine there is pre-ignition. Okay. Thereafter, SI fuels should have long delay period to avoid the knocking. CI fuels should have short delay period to avoid the knocking. Okay. So these are the main differences between SI and CI knocking that we have studied. Okay. So that's it in today's session. In next session, we will discuss more about the combustion, and we have already discussed today about the knocking and detonation in SI and CI engine and the main comparison in SI and CI engine. Okay. So we will try to solve all the queries in some of the next lectures. Okay. So if you have any query, you can also write it in comment section. I will solve as soon as possible. Okay. So that's it in today's session. Thank you. And yes, keep learning.